Hi everyone, this is Murli Manohar. Today I am going to discuss the previous year questions of GATE 2025 in electrical engineering branch. This question is based on transient analysis of RC circuit and basic circuit equations like KVL and KCL. So in the above circuit, the switch S closes at t is equal to 0 second, and what is asked is time capacitor takes to charge to 50 volt. So first we'll convert this current source to voltage source. So while converting, a resistance will come in series with a voltage source, and it will be 25 into 3 75 volt. So now the capacitor voltage at any time t will be capacitor voltage at any time t will be so this is the capacitor voltage at time 0, and this is capacitor voltage at infinity time after the switch S closes. So we need to calculate two things, Vc0 and Vc infinity. To calculate Vc0, we'll have to analyze the circuit at t is equal to minus t, because capacitor does not allow sudden change or abrupt change in the voltage. So voltage at t is equal to 0 minus will be same as voltage is at time 0 or t is equal to 0 plus. So at t is equal to 0 minus, circuit at t is equal to 0 minus, this switch S is in open condition. Since the source is connected to this capacitor, so at t is equal to 0 minus, this capacitor must be fully charged. If it is fully charged, it will be in a steady state. In capacitor in a steady state acts like open circuit. So at t is equal to 0 minus, I will redraw this circuit. This switch is also in open condition. .75 volt. Let us suppose this is capacitor voltage at t is equal to 0 minus. So the circuit is not closed, so current flowing through the circuit will be 0. By applying KVL in this loop, we can get the Vc0 minus. So just by applying, I will start from here, minus 100 plus Vc0 minus, because there is no current through 25 ohm or 2 ohm, so there will be 0 voltage drop, and plus 75, it will be 0. I have just applied the KVL equation, so from here we can get the Vc0 minus, and it will be 25 volt. I got this Vc0 minus, so this 25 volt will be the voltage across capacitor at 0 also, at 0 time also. So this will be equal to Vc0 also. Now we need to calculate the Vc infinity. So for this I will have to, let us suppose t tends to infinity, means infinity means after the switch S closes. At this time also this will be open circuited, capacitor must be fully charged because of this 100 volt, and it will be in a steady state. In a steady state, capacitor acts like open circuit. Now the switch S is closed. This is 2 ohm, 25 ohm, and this 75 volt. At this time also, since this is open, the current from this 75 volt will flow only through this 25 ohm, and the current through 2 ohm will be 0 because this is in open condition. So how can we get this VC0? The voltage across this point and this point is 0 because it is shorted. So I can calculate this VC infinity just by applying KVL. VC infinity, and the voltage drop across this 2 ohm resistor is 0 volt, so here it will be 0. VC infinity is 100 volt. Now I have this VC0 and VC infinity. Now I need to calculate this R equivalent. What is the value of C? It is given in the question. It is 5 farad. How you can calculate this R equivalent? R equivalent is just same as Thevenin equivalent. So how to calculate R equivalent? If you will calculate R equivalent, you will have to draw this circuit at t is equal to t greater than 0 time, and we will have to open the calculate R equivalent. We just open the current source and short the voltage source. So just wait a minute. How I can draw this circuit? This source will be 0 here, this will be 2 ohm. Let us suppose this capacitor is here, and now the switch is in closed condition. This is 25 ohm. We'll have to make this source short. So if you see from here, if it is short, this 25 ohm resistance gets shorted because the switch is in on condition. So R equivalent here, this is 5 farad. Okay, R equivalent will be how much? 2 ohm. Now I will put all the values in the above written equation, like in this equation. So I will rewrite this equation here only. So let us suppose VC at t time is equal to VC infinity plus VC0 minus VC infinity e to the power minus t upon R equivalent C. We have given that the capacitor voltage is 50 volt. We have to calculate the time. What is the VC infinity? VC infinity is 100 volt. So this is 100 volt. What is VC0? VC0 is, I think, 25 volt. So here we can write 25 minus 100 minus t divided by, this is 2 times 5. Okay, so we have to calculate this t. How we can calculate? Like it is minus 75 10. From here we can calculate, like if this 100 comes this side, so it will be minus 50 minus 75 e to the power minus t by 10. From here e to the power minus t by 10 will be equal to 50 by 75. Okay, so if we take log on both the sides, it will be minus t by 10 equal to ln 50 by 75. So if you calculate the time, from here it will be minus 10 times ln 50 by 75. If you calculate it, it will be I think 50 by 75 and ln, okay, this should be multiplied by 10, so it is coming 4.054 second. This value is less than 1, so overall value will be negative, and this negative multiplied by this negative will get the answer as positive. So after the switch turns on, after 4 seconds, the capacitor will reach the voltage of 50 volt. Thank you.